Recent research has increasingly pointed to vitamin D as a potentially valuable tool in slowing the biological clock, especially when it comes to the preservation of telomeres, the protective caps at the ends of chromosomes that naturally shorten with age. Among the various lifestyle and nutritional strategies under investigation, vitamin D supplementation has attracted growing interest due to its multifaceted role in immune regulation, inflammation control, and gene expression. Particularly compelling are findings from large-scale, population-based studies suggesting that a consistent daily intake of vitamin D3, often around 2,000 IU, may modestly slow telomere attrition, especially in individuals with initially low vitamin D status or elevated markers of systemic inflammation. The biological plausibility of this relationship is grounded in well-established pathways. Vitamin D functions not just as a nutrient, but as a hormone-like signaling molecule, exerting its effects primarily through the vitamin D receptor, VDR. When activated, VDR influences the transcription of hundreds of genes, many of which are directly involved in cell cycle regulation, DNA repair, and oxidative stress response. These are precisely the mechanisms that contribute to telomere shortening over time. Oxidative stress and chronic inflammation are among the most potent accelerators of telomere erosion, and vitamin D appears to counter both by promoting anti-inflammatory cytokine production and reducing reactive oxygen species. This creates a more stable cellular environment that may extend the functional lifespan of immune cells, especially lymphocytes, where telomere length is often measured. What makes this area of research particularly exciting is the accessibility and safety profile of vitamin D supplementation. Unlike more experimental interventions, vitamin D is already widely available, affordable, and generally well tolerated when taken within recommended limits. Its potential role in telomere maintenance adds a new dimension to the already broad spectrum of its health benefits, which include enhanced immune function, better bone health, and reduced risk of chronic diseases like cardiovascular disease and type 2 diabetes. The convergence of these benefits suggests that vitamin D could act not only as a preventative agent, but also as a low-risk adjunct to broader anti-aging or longevity-focused strategies. It's also worth noting that vitamin D's effects on telomeres may be more pronounced in populations under chronic physiological stress, such as individuals with obesity, autoimmune disorders, or those living in areas with limited sun exposure. In these cases, vitamin D status tends to be suboptimal, and correcting this deficiency could yield both general health improvements and telomere preservation. Some observational studies have even linked higher serum vitamin D levels with longer telomeres in a dose-dependent manner, although these findings remain correlational and should be interpreted with caution. Nonetheless, the growing body of evidence positions vitamin D not as a magic bullet, but as a meaningful, science-backed part of a holistic approach to healthy aging. It reinforces the concept that small, sustainable interventions can yield long-term benefits at the molecular level. Future clinical trials with more rigorous control over dosage, baseline status, and confounding variables will be essential to confirm causality and better define the optimal conditions for benefit. But even now, with the current data, vitamin D emerges as a promising candidate in the pursuit of extending not just lifespan but health span.